Hello everyone. In this video we're going to be solving a very exponential and logarithmic equation. We have x to the power 1 over ln x equals e to the power x. So you pretty much everything. You have ln x, you have e to the x, you have x to the power something, so on and so forth. I'll be presenting two methods and I'll show you a graph at the end. So let's start with the first method. So for my first method, I'm going to start by taking a look at the exponent for the left-hand side. The exponent for x is this one. Notice that when you write something like a to the power b to the power c, it's understood to be a to the power b to the power c like this, not like that. Because if you write it that way, this is basically going to be a to the power bc. You either use parentheses or write it as a to the power bc. All right, so let's go ahead and take a look at the exponent first. So what do I have? I have x to the power 1 over ln x. By the way, we've done quite a few problems, I think, on this one, so you can go ahead and take a look at these videos, obviously, if you want more information, but I'm just going to quickly go over this. X to the power 1 over ln x, let's just go ahead and call that y, and then ln both sides. And obviously we have some restrictions here we forgot to talk about. Ln x should not be 0, so x should not equal 1. And x has to be positive because we have ln x, so we need to make sure it's well defined. Okay, so we have those conditions. X cannot be 1 and x has to be positive. Any positive number besides 1. So if you go ahead and use the power property, which tells us that, hey, you can go ahead and move this to the front. So now we have something nice, 1 over ln x times ln x equals ln y. And now ln x cancels out, leaving us with 1 on the right-hand side, or left-hand side, but I'm going to write it on the right-hand side. So this gives us ln y equals 1. And that just means y equals e, Euler's number. Okay? So let's go ahead and plug it in. We had x to the power 1 over ln x equals e to the x. Now we're going to go ahead and replace this with e, because that's y. So x to the e equals e to the x. We've also done this video before. You can go ahead and check that out. But the answer from here is going to be as simple as x equals e. Because e to the power e equals e to the power e. Makes sense, right? Okay, great. So let's go ahead and take a look at the second method now. And for the second method, I used a different approach, even though it turns out to be pretty much the same thing because, you know, at some point we have to ln both sides, right, to bring all these powers down. Anyways, but it just has a different approach to it. Okay, so let's see. We have x to the power 1 over ln x equals e to the power x. Great. So what am I going to do? Ln both sides, right? Okay, let's do it. So if you ln both sides, ln this and ln that, the powers are going to move. This time, the power is this one, and here it's this one. Let's go ahead and move this to the front. X to the power 1 over ln x times ln x equals x times ln e, but ln e is equal to 1. By the way, let me tell you why it's 1. Because ln is base e, so when you have log e with base e, that is 1, because if you have log a with base a, it's 1. By definition of logs, this just means a to the power 1 equals a. Make sense? So logs are easy if you know the definition. Great. So this is x times 1, which is x. Awesome. So there's a lot of ways you can go about it. Obviously, you could ln both sides. You could put the x's together and then ln both sides. I don't think it's going to matter that much. So I'm going to put the x's on the same side first, because we have two expressions with the same base, so why not combine them, right? So we're going to go ahead and divide both sides by x to the power 1 over ln x. That's what I'm doing basically. And then this is going to be 1. Of course, we have these conditions still. X does not equal 1 and x is positive. And x should not be 0, but it's not going to be 0 because we said x is positive. So we're good. Now we have the following. Ln x equals x to the power 1 divided by x to the power 1 over ln x. So how do you interpret that? Since we're dividing two powers with the same base, and then we're going to subtract the exponents, right? So we can write this as x to the power 1 minus 1 over ln x. And this looks complicated, doesn't it? You can definitely always guess and check. You could have done that before, but let's make it simpler. Let's make it more manageable. So can we just use this, move this power? We can't. We have to ln both sides. But before we do, let's go ahead and simplify the right-hand side a little bit. So I want to make a common denominator here and write this as ln x minus 1 over ln x. Okay, that is my exponent. Now let's ln both sides, because when we ln both sides, we're going to get rid of the power, right? So ln x, and you're going to have double ln, which is kind of cool. All right, great. Now we can go ahead and move the power to the front. This is going to be moved. And we're going to get ln x equals, so ln x minus 1 over ln x is going to be the coefficient now, or a factor, whatever, times ln x. Nice. There's actually a good reason we do this, not only to get rid of the variable exponent, but also to simplify things. Notice that ln x cancels out, leaving us with something simpler. And of course, we always have to make sure ln x does not equal 0. Now we get ln x equals ln x minus 1. Now how do you interpret this? Okay, here's a couple of ways to go about it. You can put the ln's on both sides and then combine them, or should I say condense? Yes. Or you can use some properties on the right-hand side. Either way is fine, doesn't really matter. Let's go ahead and do it that way first. So I can just write this as ln x minus ln e. And then using the property log a minus log b equals log a over b. So that difference of logs turns into the log of a quotient. So we can write this as ln x over e. Properties of logs are easy and very helpful. So we have the following. Let's put that in parentheses. Now we have ln's on both sides, so you can do e to the power of both sides and get rid of the ln's, or just very unrigorously cancel out the ln's and just set these equal. I know it's not mathematical or rigorous, but nobody cares, right? Hopefully. Okay, we get the following from here. Now this gives us another equation, and obviously there's a lot of different ways to look at it. For example, you can kind of write this as ln x over x equals 1 over e, and then go about solving it. 2 days ago, remember, we made a video on ln x over x equals negative 1 over e. You can take a look at the solution as well. Or we can do cross multiplication, ln x equals x, and then move this e over here, write it as ln x to the power e equals x. And remember, ln is base e, so you can use the definition e to the power x equals x to the power e. That's what you get, and from here x equals e as before. So there's a lot of ways to go about it. I'm not going to make it too long because I just want to show you the graph. And here's the graph of y equals x to the power 1 over ln x, and y equals e to the power x. They intersect at one point. First of all, the green graph is going to be above, and then the red one is obviously going to grow much faster because it's the super exponential, and they're not going to intersect again. And the solution is x equals e as before. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.